So we'll look at what example 2 wants us to do from this section. So example 2 says we want to find f prime of 3 for f of x equals x squared minus 8x. And this time we'll use the first limit definition for the derivative. So we'll look at what's the limit as h approaches 0 of f of a plus h minus f of a, all that over h. So we're going to try to calculate, this would be the equation for f prime of a. So we're going to use this to calculate f prime of 3. So I'm going to do some scratch work. So we're going to let the a's be replaced with 3. So what we're really trying to find is f of 3 plus h minus f of 3, all that over h. So I want to find what is f of 3 plus h. Well, this will equal 3 plus h squared minus 8 times 3 plus h. So that will equal 3 times, we're going to set up for FOIL. Instead of doing this in our head, let's just write it all the way out. The negative 8 can distribute, so we'll get negative 24 minus 8h. 3 times 3 is 3 squared, which is 9. I have 3 h's from the outer and 3 h's from the inner. 3 h's plus 3 h's adds up to 6 h's. Then h times h is plus h squared. I have minus 24 minus 8h. So let's write this as the h squared term first. 6 h's take away 8 h's is negative 2 h's. And then let's see here, let's say we got 9 and we're going to take away 24 from it. So we want to do 9 minus 24, which should be negative 15. Okay. So that is f of 3 plus h. Let's find out what is f of 3. So I know what we're looking for, f of 3 plus h minus f of 3, because again, remember, a is 3 because that's what's in the parentheses that we're trying to evaluate. So f of 3 would be 3 squared minus 8 times 3, which is 9 minus 24, which is 15. Whoops, just kidding, it's negative 15. 9 minus 24 is negative 15. So we're going to look at f prime of 3. That is the limit as h approaches 0 of f of 3 plus h minus f of 3, all that over h. So this whole bit replaces the symbol f of 3 plus h, and this replaces the symbol f of 3. So we get h squared minus 2h minus 15, so all of that minus a negative 15, all that over h. So this will be the limit h approaches 0, h squared minus 2h minus 15 minus the negative 15 is plus 15, all that over h. The minus 15 and the plus 15 cancel. The bottom term and both the top terms have at least one h in it, so the h down here will cancel into each of the top terms' h's, and we'll get this equals the limit as h approaches 0 of h minus 2. So if we let the h approach 0, then h becomes 0, this becomes 0 minus 2, which is negative 2.